All right. So this is not one of our regular weekly Monday night sessions, but we have for midterms, and we'll do the same on final exams. There'll be a Saturday session, the Monday session, and then a Tuesday afternoon session. So there are recordings available from the Saturday and Monday midterm review sessions. So those went over on Saturday, covered number 8 and number 20 from that midterm review PDF that you got sent. And then Monday covered number 16, 17, 11, and number 1. So you can check out those recordings for those questions. I have a request for number 12. That on my list. So, and I'll show you real quick, or I think it's on here. So you should be hearing audio right now. You have the instructions here, so hopefully if somebody is not hearing audio, they are following these instructions. If you don't hear audio, check the volume level on your computer, make sure the volume is turned up, use the sound check link under the audio settings to test. And if you continue to have issues, you can call the Zoom tech support line. Yeah, she did the number 1 that was covered at the end of Monday's session. She re-recorded corrections, but I can go over that as well. 16B. Okay, so you're asking questions with the chat. I think you can also participate with your microphone and reactions. But yeah, here's the link for the feedback session that you can use whether you're watching the recording or attending live. So I'm just going to put that link into the chat as well. Great. And then just to review the schedule, you should have links available to this in your course or sent to you or various, but this is where you'd find then the Zoom recordings. So let's see. So yeah, you have the recordings from Saturday, and there is the recording of the correction from problem number 1 as well. So you have those available. I just want to remind you to familiarize yourself with the formula sheet. So it has the quadratic formula. So if you have any doubts whatsoever about that formula, you don't have to have it memorized. It's on the formula sheet. You have the uniform motion formula, working together, as well as some. And I think the only things that you would use on the midterm would be these first 4 things. Everything else would be later. So if you're trying on the midterm, trying to use any of these formulas, starting with the compound interest, you're not using the right thing. But it's always good to be aware of what formulas you'll be given, so that you know, and then what you're not given. So I'm going to start by looking at that homework question. The what you see on like that midterm review that you got as a PDF and the study guide, that's going to match up fairly well with what you'll see on the midterm review. You also have the practice quiz, the review quizzes, and the practice tests. If you're taking on campus, they should give you a copy of the formula sheet. So you shouldn't, they won't let you bring it in actually, like they will give it to you, or they may allow you to view it on screen as well. So make sure you know where that's located within your course, in case they want you to do that. But yeah, you may be more specific with the question about the fractions. If it's not in any of the review materials, then it's probably not going to show up on the exam. But I don't want to Like there probably will be stuff somewhere with fractions. I don't know more specifically than that. All right, so I'm going. Remember, if you go to the Ivy Plus bookshelf launch and go out to the Pearson site, that gives you access to past homework assignments. It also gives you access to the study plan. So there's things you can get to that way that if you just look at the assignments within IvyLearn, you won't see. So, all right, I'm going to take a look then at the review homework number 41. And I will say, I don't think you have questions exactly like that one on the exam, but it's just it's a chance to review transformations, so I'll still take a look at it. So the one that I'm doing, it'll have a little bit different numbers probably than what you're looking at. It'll still be the same process. So we're starting with the basic x squared, right? So we have the vertex at 0, 0, and going through the 0.11. But we're looking at then this transformation. So looking compared to x squared, there are 3 things that have changed. We have now a 2 out front. We have an x minus 2 being squared instead of just x, and we have a plus 1. So the 2 out front is being multiplied. That is a vertical. Anything outside of this, so it's not within what's being squared, it's outside of the square, it's going to be a vertical change. And when you multiply by a number, that's a stretch or compression. Since it's larger than 1, it's a vertical stretch. So I'm looking for a description that has a vertical stretch. A compression would make it shorter or flatter. That would be like making it a number smaller than 1, so like 1/2 or 2/3 or something. The minus 2 inside is a horizontal shift, and subtraction inside shifts to the right. So I'm looking for a horizontal shift to the right by 2 units, not left. And then the plus 1 outside is a vertical shift up 1. And so I'm looking for up by 1 unit, not down. So that narrows it down to B for that description of the transformations. But then looking at the points, and that was the question you had. So using the graphing tool, then it looks like we have the transformation tool. So it just says click the graph. So I can click literally anywhere on the graph. It'll give me that initial x squared graph. And so I need to put the vertical stretch. So that's going to be 2 there. And you see that stretching vertically. You're not ever going to be doing a horizontal stretch or compression. There wasn't any reflections, but there is a vertical shift up 1 and a horizontal shift right 2. Okay, so we have the graph. But then it asks about the coordinates. So they've picked 3 points on the graph of x squared. So the first part, the first column, I'm just filling in the square. So -2 squared is 4, 0 squared is 0, 2 squared is also 4. But then when I look for corresponding points on the graph of this transformed function, what I want to look at is any inside changes are going to change the x value. What I want to look at is what would I have to plug in for x to get -2 and to get 0 and to get 2 being squared. So if I have -2 squared, I'm looking at if I have x minus 2, what is x? So that would be 0, and then +2, and then +4. And you can see then we had that shift to the right 2. So the 0, 0 point became 2 something because it shifted to the right 2. So I'm shifting all of those x values 2 units to the right. -2 becomes 0, 0 becomes 2, 2 becomes 4. And then for the y coordinate, I'm taking that y coordinate and it is getting multiplied by 2, and then 1 gets added on. So the 4, we're going to have 4 times 2 plus 1, so 9 for that. And you can see the point 0, 9 on this graph. Then the 0 multiplied by 2, still 0, add 1, it's the 0.21. And you can see that also on the graph here, 2, 1. And then 4, 9 again, because we're still taking 4 times 2 plus 1, and you see that point on the graph. So you're just looking at what those transformations do in general. We say it shifts the graph to the right 2 units, vertically stretched, vertically shifted. What does that actually do to the ordered pairs? But this ordered pair part, I'm pretty sure you will not have on the midterm. Do be able to identify what those transformations are, graph using the transformation tool. But that's mainly what you need to be able to do. All right, so, but hopefully that helps with that homework. All right, going then to the actual review, the PDF review that you got. We're looking at number 12 to start with. Okay. All right, so number 12, we have this graph and we're looking for the intercepts, domain and range, intervals where it's increasing, decreasing, or constant, and whether it's even, odd, or neither. So the intercepts, we're looking for any points that are on either the x-axis or the y-axis. Okay, and so that is this point right here and here, 0, 0, and 3, 0. An intercept as an ordered pair will always have 0 as at least one of the coordinates. Because it just asked what are the intercepts and it didn't specify x-intercepts or y-intercepts, it does want the ordered pairs, and it says type an ordered pair. So that's exactly what you would put in there, those ordered pairs separated by a comma. You could have them in either order as far as which ordered pair you list first, but you'd need to have them in that form. So you're not just going to say 0 and 3 listed separately as the x value and the y value, because there's nothing to tell what those are, whether they're an x or a y. For the domain, you want to think the domain is the x values, and you want to think left to right. So you can kind of think of, if we have a wall as tight as possible against the graph, or if you think of collapsing the graph kind of onto the x-axis, what part of the x-axis does it cover? And we're going from -3 to +3. Then you look at the endpoints. As long as you don't have an open circle or an arrow, then it's going to be square brackets. So if there was an open circle or an arrow, you would use parentheses. Listing left to right, that interval with square brackets, because those endpoints of -3 and +3 do have actual points on the graph. For the range, you're looking at the y values. You want to think bottom to top for that, because you're giving an interval that has to be least to greatest. So here you can think of like a floor and a ceiling that are getting as tight as possible onto the graph, or you can think of collapsing that graph onto the y-axis, and it's going to cover from -1 to +2. Again, with square brackets, there were no arrows or open circles on this graph, so there's not going to be parentheses on those on the domain and range. All right. So then we have the increasing, decreasing, and constant. My recommendation is don't answer the increasing, then answer the decreasing, and then answer the constant. You want to look at the whole graph from left to right on the graph and figure out the pieces. So I start at the left side of the graph at -3. For these, for the increasing, decreasing, and constant, you're giving intervals of x values. You're not giving anything to do with the y values. You're not giving ordered pairs. You're looking at the piece of the x-axis that corresponds. So this first piece of the graph, the first step is just be able to identify the pieces. I think that's the easy part. The hard part is getting the right notation. So we have this piece of the graph here where it's constant. And then this next piece, it is decreasing. Then we have a little piece where it is constant again. And then the last piece, it's increasing. But to identify those pieces, again, we want the intervals of x values. So we start at -3 and we go to -1. So that's constant. You can put technically parentheses is correct, but MATLAB will accept square brackets. And I think that helps remind yourself that this is not an ordered pair. The y values aren't coming into it at all. We're listing the starting x value and the ending x value. The next interval goes from -1 to +1 on the x-axis. And then we have that little piece from 1 to 2, and then from 2 to 3. So we're just splitting up the domain into pieces based on what the graph is doing, how it's behaving as we go left to right. So we had that one was constant. This was constant, decreasing, and increasing. So then I can put them into their appropriate pieces. So the increasing would be 2 to 3. Again, you could use that with parentheses. Just keep in mind it's an x starting x value, ending x value. Think of like if we shifted that graph up or down, it wouldn't change where it's increasing, decreasing, or constant. It's decreasing this one from -1 to 1. Again, that could be with parentheses. This is the one context where you can use either the parentheses or the square brackets. And then the constant was -3 to -1, and it says use a comma to separate answers. So rather than using the union symbol, we'll just list those two separate intervals. Question about memorizing and remembering concepts. When I was taking math classes, I would take notes of the whole section in class, examples, but then I would make a separate page of notes where it would just be like the procedures, the formulas, just sort of more concise. It would be maybe for the whole semester, a page or two total. You have something kind of like that with the study guide that has been provided, where it's just saying, these are the things that you need to know. Here's how to do the things. So that would be what I would study from. And then it kind of depends on your learning style. For me, it would be writing it over and over again. So if there was a formula I needed to memorize, write it again, try and write it without having to look, at the previous time. Some of you, it might be better, if you record yourself saying it and then listen to that, or just read it out loud over and over again. But I think no matter what your learning style, the key is repetition. Say it or do it or write it enough times, and spread it out. So, maybe do it 10 times, and then, a couple hours later, do it 10 more times. And then the next day, do it 10 more times. That would be my advice. But find the, as far as the details of it, find what works for you. Sorry, the last piece on this then is even, odd, or neither. So even is going to be on the graph, it's going to look like the y-axis is like a mirror, and then you have both sides on either side of the y-axis. We don't have that on this graph. Odd, the origin is going to be a center of rotation. So you would have, we would have to have pieces of the graph. So we would have to have like the whole thing rotated. So we'd have to have, the piece, sorry, it'd be like, yeah, down here. So we don't have that either. So this one is neither even or odd. All right, so that's number 12. Number 1 then was the next thing requested. You do have a recording of that, so I probably won't do the, it won't take too long. So quadratic formula, again, if you have any doubts whatsoever, it's on the formula sheet, look it up, but it's negative b minus square root of b squared minus 4ac all over 2a. And in this example, we have a is 1, b is negative 4, c is negative 4. So we plug those in, negative b, sorry, plus or minus square root of b squared. Use parentheses when it's a negative. So it's not just going to be negative 4 squared, but the whole negative 4 is going to be squared. Minus 4 times a times c all over 2a. So 4 plus or minus, and then what's inside? That's going to be 16 plus 16. So 32 over 2. And then because it's not a perfect square in the square root, we can't simplify it down to just whole numbers or fractions, but we do still need to do some simplifying. Some things to watch out for: you can't just cancel out the 2 with the 4. So it's not just going to be 2 plus or minus square root of 32. The 2 has to apply to both the 4 and the square root of 32. Now it's not then going to be 2 plus or minus square root of 16. We can't divide the 32 by the 2 because one's in the square root and one isn't. So I would start by simplifying the square root of 32. Well, 32 is 16 times 2. So that's square root of 16 times square root of 2. Square root of 16 is 4. So 4 square root of 2. So then we have 4 plus or minus 4 square root of 2 over 2. It might be helpful to actually write it out a separate step, 4 over 2 plus or minus 4 square root of 2 over 2, or just, again, keep in mind the 2 has to simplify with both terms. So that ends up being then 2 plus or minus 2 square root of 2. All right, and I see your requests there, Kemi, so that's down. That's number 1. I don't have anything. When I'm doing in MATH, I always like check my work to make sure I didn't make a mistake, but hopefully that's, I don't have like the answer key up to double check. But next up, number 16b. See, there is one of that type. Okay, yeah. So that's similar to the one I did that on the review homework as far as doing those points. Was that the part that you wanted to talk about? Okay. So then I think next up is number 3. All right, so here we have a radical equation. So the process for a radical equation is the first thing you want to do is isolate the radical. So you can't undo the square root. If I try and square both sides, you can't square each term individually. So I can't just square each piece. You have to square the whole side at a time. If I square the side that has a square root and something else, then because the square, if I have two things added together and they get squared, it's going to square the first thing and it's going to square the second thing, but it's also going to have 2 times the first thing times the second thing. So we would still have the square root going on. So we need to get the square root by itself, and then we can square both sides. Once you square both sides, then you should have a linear or quadratic equation to solve. And then the last step you need to do with this type of equation is you have to check for extraneous solutions. As you're doing this, this is also a double check. So extraneous solutions are solutions where you did correct algebra, you got the answers, but what happens when you square both sides is you're really like introducing a second side that isn't really there. So like graph wise, a square root is like this, and you have that other half that isn't there. If I'm looking at, where that intersects with a straight line, for example, we have this point here, the extraneous solution would be where that line intersects the like bottom half that isn't there. So that's what you're checking for with the extraneous solutions. But if you check your answers and the square root part comes out to like it's not a perfect square inside the square root, that's a big red flag that you actually have incorrect. It's not just an extraneous solution even, but you've messed up something and you've made mistake and you have an actual wrong answer. So it's definitely worth checking your answers in general, but with these especially, you might get 2 answers and find that one of them or even both of them are actually not solutions if you go back to the original equation. So doing that process here, I'm going to first add 3 to both sides to isolate the radical. Now I can square both sides, squaring the entire side. So now the square is, undo the square root with that. So I just have 2 times x plus 27 on the left side. Squaring x plus 3, again, you got to have the correct process for squaring the binomial. It's not just going to be x squared plus 9. It's x squared plus 6x plus 9. So that's, again, it's either square the first thing plus 2 times the first thing times the second thing plus square of the second thing. Or if you're more comfortable writing it out, squaring something is multiplying it by itself. So x plus 3 times x plus 3, FOIL that out. So you get x squared plus 3x plus 3x plus 9. Have some sort of process where you're correctly squaring the binomial. That's the most likely. If you do correctly isolate the radical and then get something wrong along the way, probably you didn't square the binomial correctly. I'm going to distribute the 2 here and then move everything to one side of the equation so that I have can solve a quadratic correctly. So I have x squared plus 4x minus 45 equals 0. I'm going to see if I can factor that. So 45, 5 times 9. If I make that a -5 and a +9, those multiply together to get -45 and add together to get +4. So I get then my potential solutions of 5 and -9, but I have to test those back in the original thing. So square root of 2 times 5 plus 27 minus 3. I'm testing, does that actually equal 5? Well, so 5 plus 27 is 32. 2 times 32 is 64. Square root of 64 is 8. 8 minus 3 is 5. That one checks out. If I do -9, square root of 2 times -9 plus 27 minus 3. So I'm testing, does that equal -9? Well, let's see. -9 plus 27 is 18. 2 times 18 is 36. Notice it still comes out a perfect square. So that tells me it's probably is, I didn't mess up the algebra, right? If it came out square root of 17 or square root of, something that wasn't a perfect square, then I've probably actually made errors. But here, 6 minus 3 is 3. When you have the extraneous solutions, you can kind of recognize with these radical, if this had been negative square root, that would be what it would take to make it come out -9, but it wasn't. It was just the positive side of the square root. So we only get the positive side answers. So -9 would be extraneous. So you would leave that out of your solution set and it would just be 5. Depending on your instructor, if you put 5 and -9, you probably get some amount of partial credit, but you'd still get at least some part taken off for not eliminating the extraneous solution. Okay, next one then, that was number 3, number 9. All right, so we have stopping distance with the reaction distance and braking distance. And we have a formula for the reaction distance and the braking distance. So the stopping distance is going to be the result of adding those two together. So we're taking the R of V, which is 2.2 V, plus the braking distance, which is 0.04 V squared plus 0.4 V minus 15. Now, I want to say you have this where you're adding the two functions. If you were subtracting the two functions, then you would have to watch out that you wouldn't just take 2.2 V minus 0.04 V squared plus 0.4 V minus 15. You would have to subtract the whole thing being subtracted. And so you would apply and it would be minus 0.4 V squared minus 0.4 V plus 15. So changing signs on all of those pieces. So just watch for that. This one happens to be addition, so it is a little less tricky than if it's subtraction. So you'd have 0.04 V squared plus 2.6 V minus 15. So it says the V, speed of V miles per hour. So V represents the speed. So if we have 60 miles per hour, that's a value for V. So we would plug that into the function. So 0.04 times 60 squared plus 2.6 times 60 minus 15. I'm not going to take time to actually calculate that, but that would be what you would do. And then that value, then what is giving D of V is giving the stopping distance. So whatever you get out of there is the stopping distance. So that's including for the driver to react and brake. So they'll need that, I think, to stop once the impediment is observed. Once they see it, they have to react, they have to brake. Total distance isn't really clear. I think it wouldn't, like, I would have to say the total distance covered by the vehicle once the impediment is observed. So I'd kind of combine A and B. But while the driver moves their foot to the brake pedal, that would be R of 60. That would be the reaction time. And then once the brakes are applied, that would be the braking time. So C and D are parts of that. But that would be and then that's the unit. So the unit on the result would be feet. You're finding the stopping distance in feet. So that's what that's going to. So you're putting in a miles per hour, you're getting a number of feet. Number 19, we'll see, I'll do number 6, and then number 8, well, okay, number 20 was covered on Saturday. 19 is similar, but I think I'll have time to do it. So number 6, though, bank loaned out $16,000 at 6% per year, the rest at 16%. The interest received was $2,000 for 1 year. How much was loaned at 6%? The way I approach this, I'm not going to directly try and calculate the 6%. I'm going to set this up as 2 unknown values. So I have the amount at 6%. I'm going to call X, and then the amount is 16. I'm going to call T. I'm trying to come up with variables that kind of match what's going on. That's a little hard with the numbers. So the first thing I know is that those 2 amounts, so I have the amounts loaned. So I have the 6% and the 16%, and I have the total amount. Those need to add up to 16,000. Then I have the interest. The total interest is 2,000, and I'm using basically the I equals PRT, but T is 1. So I'm taking the principal, the amount loaned, times the interest rate, decimal form of the interest rate. So 0.06 times X, that's the interest earned on the 6% amount. And then 0.16 T is the interest earned on the 16% amount. If you look at this type of question on MATLAB, they'll have you go straight to the combined. So what I'm going to do is I'm going to say then X can equal 16,000 minus T, or I can say T equals 16,000 minus X, and I'm going to substitute. Since I really want to find X, I want to substitute and get rid of T. So I'm going to replace T here with what it equals. So I get 0.06X plus 0.16 times 16,000 minus X equals 2,000. To me, it's confusing to try and go straight to this step because it's less clear where the numbers are coming from and what number should go where. If you set up the 2 equations and then combine them, I think you'll get the correct setup more easily, and you'll kind of understand where the pieces are coming from. But then at that point, then you're just solving that equation for X. So I'm not going to take time to do that solving process. I assume you can do that, but it's getting the setup. Okay, so number 19 is one of those big, messy, rational equations, I'm assuming. And so we will take a look at that. All right, so number 19, we have x squared over x squared plus x minus 2. And you have this whole process that MATLAB takes you through. So the first step is factoring. So like the x squared on top, that's already factored. We don't need to factor it, but the bottom we can factor. So that's the first thing to note. Like if it's already factored, then you would just choose that. You wouldn't retype it. But that's not what we have in this case. So this factor is we can get a 2 and a 1, and that would be a +2 and a -1. Factoring, like it's assumed throughout this course that you're comfortable factoring. It came up in chapter 1 and has continues to come up. If that's something you struggle with, you can go, there's different places you can practice. The study plan will you can go and find factoring practice. You can go on Khan Academy. but it's something, it's like, it's a great big pillar that other stuff is being built on. If that pillar has big little cracks in it and it's falling apart, like everything else is going to come crumbling down. So you want to be able to focus on the new stuff, the rational function stuff, and not have just your factoring be messing you up. But so that's the factored form. And then it asks about the domain. So the domain it's going to be x not equal to zeros of the denominator, because we can't divide by 0. So we want the x not equal to form, and we're just going to put in then the -2 and the +1. So if you need to set those factors equal to 0, but it's, you know, what's going to make each of those factors 0. Then it asks for the simplified form. So if we did have factors on the top and the bottom, the same factor on the top and bottom, that would then that factor would cancel out, but it's still going to have to be excluded from the domain. So that's why they asked the domain first and then the lowest terms. This one didn't have any simplifying to do, so you want to choose it's already in lowest terms. You don't want to rewrite the function. So then it asks about the intercepts. So x-intercepts are going to correspond to that's going to be the zeros of the top of the numerator. So looking at x squared, what makes x squared equal 0? That's just going to be 0. And then as soon as you have an x-intercept of 0, the y-intercept is also 0. But the y-intercept is always, you plug in 0 for x. Just be careful when the whole top is 0, then it doesn't really matter what's on the bottom. As soon as we're dividing by 0 divided by anything is 0. So I'm going to start sketching a graph. So we have 0, 0 so far. All of the factors, you want to kind of start thinking ahead to you're going to have that question about above and below the x-axis. All the factors on the top and the bottom, including if there's one that gets canceled out, those are all going to be used to divide the x-axis into intervals. So we have -2 and 1 and 0. So that's going to divide the x-axis. We're going to go from -infinity to -2, and from -2 to 0, and from 0 to 1, and from 1 to infinity. Those are the intervals. Those are the pieces that are going to make up the answers to the above and below the x-axis question. So we'll come back to that. But all right. Moving on then, it asks about the behavior at the x-intercept. So that's determined by whether the factor was squared or not. So squared means that it just touch and not cross, versus a not squared factor. And that's simplifying a little bit. Any even power would touch and not cross any odd power, but it's almost always just squared or not squared. Not squared, it would actually cross. And in this case, we had the x squared, so it's going to touch. So no crossing, just touching. So touch but not cross at x equals 0. So that tells me, going back, that tells me at 0 that it's going to be the same on both sides. It's either going to be positive on both sides, above the x-axis on both sides, or below the x-axis on both sides of that x-intercept. All right, then we have the vertical asymptotes. Those are going to match up to the bottom. So that's going to be x equal to, and that's going to be the zeros of the denominator, excluding any, like if it's simplified, it'll be the zeros of what's left. But in this case, nothing simplified. It's just going to be x equals 2. Sorry, it's separate. So it has 2, -2 and 1. And so we're going to go with 2 vertical asymptotes. And we want to go left, right. So starting with the x equals -2, and then the x equals 1. So you have to be a little careful there of not just coming up with the formulas, but putting them in the right place where it wants those. So again, we have those, and the behavior there, because neither of those factors was squared, so squared factors would be the same on both sides. So we would have, the asymptote either going towards infinity, towards y values of infinity on both sides, or negative infinity. A not squared is going to be opposite. So it's going to go towards infinity on one side and negative infinity on the other. And that's what we have in this case. So we need to find, see the infinity on one side and negative infinity on the other. We don't have the infinity or negative infinity on both sides. So we have one side, negative infinity on the other for both the -2 and the 1. And so that tells me, going back to the above and below, that at the -2 and at the 1, it is going to change. It's going to be above on one side and below on the other. So if the top was just x, then it would cross at 0, but since it's x squared, it's just going to touch and not cross at 0. Does that answer your question on that? All right, so then we have the horizontal and oblique asymptote. You want to think of these really as one question, because you can have a horizontal or an oblique. You can have neither of those, but you're never going to have both. And the way to figure them out, it's one process. So the process you have is you look at the leading term. So we had this. So we look at the leading term of the top and the bottom. So if that came out to a multiple of x squared or higher, then you would have neither. There would be no horizontal and no oblique. If it comes out a multiple of x, then that's when you have an oblique asymptote. It's going to be y equals, it's going to be like y equals mx plus b, but you have that multiple of x already, but you have to do long division to find the b. If it just comes out a number, then you put y equals in front of that number. That's a horizontal line, a horizontal asymptote. And if it comes out where there's any power of x on the bottom left, then that would be y equals 0, which would also be a horizontal asymptote. In this case, we have x squared over x squared, which equals 1. So we stick y equals in front of that. It is a horizontal asymptote. And so that means there is no oblique asymptote. There will never be 2 horizontal asymptotes. There will never be 2 oblique asymptotes. And then you have the question about, is there an intersection? So you would take the function, so we take the x squared over x squared plus x minus 2, set that equal to 1, and see if there's any solution. So if I multiply both sides by the x squared plus x minus 2, I get x squared equals x squared plus x minus 2. If I subtract x squared from both sides, I get x minus 2 equals 0, and that comes out x equals 2. So that would be the x value. They want an ordered pair, so what's the y value? Well, the whole way I found this was saying what x value is going to give a y value of 1. So we have that. So I have now on the graph a horizontal asymptote. I have the graph having a point intersecting 2, 1. So intersecting that horizontal asymptote. And then I have the vertical asymptotes. And putting that together with the behavior. So I know, so the graph is going to flatten out along that line y equals 1. And then it can't cross over. So it can't from here go down because it has to flatten out alongside the vertical asymptote. So it has to go up there, but then it has to switch. So it's going to be down alongside the vertical asymptote on the other side. It's going to touch at 0, and then it's going to go back down again. And then it has to be opposite on this vertical asymptote on the other side. So it's going to be up. And so it's going to flatten out along the y equals 1 to the left. So we have then above the x-axis on the interval from 1 to infinity for those x values, for x values between 0 and 1, it's below. Between -2 and 0, it's still below. But we can't just combine those into a single interval and say -2 to 1, because at 0, it's not below the x-axis, it's on the x-axis. Then for x values between -infinity and -2, the graph is above. So then we just put those intervals into their pieces. So above the x-axis was -infinity to -2 and 1 to infinity. And then below was -2 to 0 and 0 to 1. We're just putting those, separating the intervals with commas, not the union of set. So it says use a comma. And then I'm just looking for the graph that matches that. So B is out because it only has one vertical asymptote. Same thing with D. And then between C and A has it crossing the axis. C has. So if you sketch the graph as you're going, using that information given by the multiplicity, so whether it crosses or touches, whether it is opposite or same on each side of the vertical asymptote, the intercepts and how it behaves at each intercept, and then any additional points. You need one point that's not on the x-axis in order to come up with the above and below, and then you can follow the pattern, or you can do a test value on each interval. But if you sketch that graph, then it should be a fairly simple matter of finding the graph that resembles that. So that's number 19, and we have a few more minutes. So any other, number 15 has been requested. So we'll look at number 15. All right, so number 15. So here you're writing the equation produced by doing these transformations in the order given. So what you want to watch for on this is note that vertical transformations apply to the entire previous step. So I'll look at another version of this also where that would matter. But here we're taking the square root of x. The first thing is reflect about the x-axis. So I didn't I have to stop and think, all right, the x-axis is horizontal, so we're reflecting it. So that's actually a vertical reflection. A reflection is going to apply a negative. But because it's vertical, it's going to be outside. So I change the square root of x to a negative square root of x. Then shifting down 8 units, I'm going to subtract 8 from that. And then the shifting left 5, I'm going to replace x with x plus 5. But let's say 1 and 2 were switched. So what if it was first shift down 8 and then reflect about the x-axis? So then I would have the square root of x minus 8, but then I would have to apply that negative to the entire previous step. And I would get negative square root of x plus 8. So it's the difference between taking your square root graph, reflecting it, and then shifting it down, versus if I take the square root graph and I first shift it down, And then I reflect that shifted graph about the x-axis. Now it's changed that shift down to a shift up. So watch out for that. But this particular example, that wasn't an issue, but it could be on the actual exam. So you want to know what to do depending on the order that you're doing those transformations, in the order they come, and then know the transformation rules to apply negatives for the reflection, shifts up and down, left and right, whether those go inside or outside, and whether they should be a plus or a minus. So this would be negative square root of x plus 5, and then outside of that -8. Transformations are never going to change the base function. So this is a square root. It's got to be a square root. It's not going to turn into a square or a cube or some other thing. Inside, if you have like x squared, let's say it's shifted left 5, sometimes you'll see something like this. Like this. That's not putting the 5 inside. Inside doesn't mean just inside parentheses. It means inside of the actual function action. So it has to be inside of the square. So it would be x plus 5 squared. So that's as far as things I see done wrong on this type of question. I'm not in charge of posting the recordings. Hopefully they'll get them posted. I don't know what the timeline has been. They did have, like, looks like the recording from yesterday was posted today, and that was a little later in the day. But I will reach out and at least pass on that request to try and get that posted as soon as possible. Any other questions? Still have a few minutes here. Let me see if I have any other. So we did 15. Good. Let's see. Number 10 is just a comment on number 10. It's similar to number 11 that we looked at, but this one, notice we do have that sort of mirror image over the y-axis. So this would be an even type of function. But it does have to exactly match. So if I have something, that looks, maybe something like this, it's kind of a mirror over the y-axis, but it's not quite. So, it does have to be a perfect reflection. Notice, like, even though we don't have dots marked, we do have 3 intercepts. So intercepts don't have to be marked with a dot. They don't have to be labeled with an ordered pair. They're anywhere that the graph is crossing or touching the x and y axis. So be aware of that. When you have these questions with, is the graph that of a function, you definitely want to be solid on that, because if you say no, and then you don't answer the rest of the questions, because if you say no, then it wants you to just say the graph is not a function. But if it actually was a function, then you've lost all of the points by not recognizing it as a function. An odd function, it might look something like this, where it's going to have, you kind of think of like spinning around the origin. If you think of like a fan spinning or a wheel spinning, but you have that sort of, that's how I kind of visualize it in my head. But you have that rotation 180 degrees around the origin, and that it's landing on top of itself. You should have, if it's odd, then if you look at ordered pairs, you should have matching, let's say, like if I have 1, 3, then I would have to also have -1, -3. So matching points with the opposite sign on both the x and y, versus even, we would have matching like we have here. We have 3, 3 and -3, 3, and we have -2, 0 and +2, 0. Like any point you pick out, there's going to be a matching point with the same y value and the opposite x value. With the origin, you would have, so this is symmetric with respect to the origin, is the same thing as an odd function. So it does have to have the center of rotation about the origin. If I have a graph that has that same thing, but the center of rotation is somewhere other than the origin, then that would not be odd. So we only care about symmetry when it's relative to the origin or to the x or y axis. As far as the graph being a function, if there's anywhere that you can draw a vertical line and it's hitting the graph more than once, that would be not a function. Both of these graphs that we see here in 10 and 11, yeah, 10 and 12, you know, those were graphs of functions. I think it's not a difficult concept. It's just like, if you don't get it, it can hurt you more so than just the one part of the question. I would say if you have any doubt over whether it's a function or not, err on the side of going ahead and answering all the other questions. Because yeah, then if you have that first part wrong, you still get the other parts. If it is a function, so you should never be answering it symmetrical with respect to the x-axis, because that would not be a function. Because we would have to have then pieces for the x-axis. You can think of like a surface of water with something reflecting on it. So you might have, you know, whatever's happening above, then you have matching below, but then it immediately is going to fail the vertical line test. So you might add answering the y-axis or the origin or not symmetrical, or it's not a function. Yeah, all right, so that's our time, and I'm not seeing any other questions, so I'll go ahead and give one last call for anything. I'm going to stop the recording then and give you another chance if there's anything you want to ask and not have on the recording. A reminder to go back to that feedback form and complete that. And yeah, you do have the recordings from Saturday and Monday, and hopefully at the latest by tomorrow, but I'll reach out and, you know, ask if that can be hurried and have the recording available even by the end of the day today from this. And then we have our regular sessions every Monday night for weeks 5, 6, and 7. And then we'll have again this Saturday, Monday, and Tuesday for final exam week. So I'll go ahead and stop the recording here.